Okay, now let us learn about electromotive force. What is actually electromotive force or EMF? Is it about a force? A force like tension, friction with unit Newton? Is it a vector quantity? No, this is actually voltage. It's not a force. Okay, it's not a force. It's actually a voltage. Okay, unit volt, not Newton. Okay, volt. It's a scalar quantity. It's a scalar quantity. It's not a vector like force. It's a scalar quantity because we know that it comes from the work done. Yeah, voltage is the potential difference or delta V. Delta V. So it comes from work done. Work done is energy. Yeah, work done is about energy. Energy unit joule. So energy is a scalar quantity. That's why voltage is a scalar quantity like energy, joule. Yeah, the voltage here. So EMF is a scalar quantity. Yeah, it's not a force. It's a scalar quantity. It's about energy. Yeah, voltage. Yeah. EMF is the energy provided for the charge that passing through the battery. Yeah. So power up the charge that passing through the battery so that the charge will have enough energy to go through the external circuit. That's actually the voltage, EMF. So EMF, okay, I can make an example. EMF is actually the, I have a battery, okay. I have a battery with EMF, let's say 15 volt, okay. Battery always have internal resistor R, okay. So this is the battery. Now, I connect this battery to the external circuit. Okay, I connect it to the external circuit. This is the resistor R. Okay, now, even though the battery has EMF 15 volt, do you think the resistor will receive the EMF 15 volt totally? Yeah, do you think it will receive it totally? If I connect a voltmeter, across the resistor. Do you think the voltage across the resistor also 15 volt? The answer is no. The voltage across the resistor only maybe written as 12 volt, recorded at 12 volt. So where is the remaining 3 volt? Where has it gone? The answer is there is voltage loss across the internal resistor. So across the internal resistor, there is voltage loss. This voltage loss is actually VR. Yeah, voltage across the internal resistor. So it has lost 3 volt. Lost 3 volt. So the external resistor, this voltage is actually VR. Yeah, big R. This is V big R. This is V small r. Yeah, V big R. So this is the voltage received by external resistor, only received 12 volt because there is voltage loss inside the battery itself. So it didn't receive the EMF. The voltage across the external resistor is less than the EMF. It didn't receive the EMF, but it received less than EMF. Okay, because when this is a complete circuit, the switch is closed. For this one, the switch is closed. So there is current flow in the circuit. You see that? When this circuit is a complete circuit, there is current flow in the circuit. So when there is a current flow in the circuit, there is potential loss across the internal resistor. Okay, which is because we know that we will discuss this because I already written here in detail. Yeah, this is I just explained the situation here. Why the resistor only receive 12 volt instead of the EMF 15 volt. I briefly explained that because there is voltage loss across the internal resistor when there is current flow in the circuit. When there is current flow in the circuit when the switch is closed. Okay. Now I explained in detail about what's really happening. Yeah. So this is the setup which I have drawn just now. Okay, but this one in more detail. If you can see over here, I have a battery here. So this battery has EMF E. EMF E. Inside the battery also have the internal resistor. So across the internal resistor is voltage loss across the internal resistor. Yeah. So across the internal resistor has VR. This is actually the voltage loss. I can say that this is actually the voltage loss. Yeah. And this is the EMF. And this is the external resistor. External resistor. Okay. Now, here you can see there is a voltmeter connected across the battery. Yeah, voltmeter across the battery. This voltmeter will record terminal voltage because this is the terminal voltage. Yeah, VT, terminal voltage. Why we say this voltage across the battery is a terminal voltage? Because you connect the voltmeter across the terminal. This is the negative terminal, this is the positive terminal, and this is the negative terminal. You connect the voltmeter across the terminal. That's why we call this terminal voltage. Okay? And here resistor, this is the resistor. We also have another voltmeter connected across the resistor. This one record the voltage across the external resistor. Okay? Voltage across the external resistor. Now, do you see how to get the terminal voltage here? How to get the terminal voltage? Okay. So how to get the terminal voltage is because we know that inside the battery we have EMF. Yeah, we have EMF and also the voltage loss across the internal resistor. So how to get the terminal voltage? We must take the EMF minus the voltage loss across the internal resistor. Minus the voltage loss across the internal resistor. This voltage loss is the VR lah, is the VR. Minus it. Then we can get the terminal voltage, which is the voltage by this voltmeter across the terminal. Yeah, the terminal voltage. And then now I further derive this voltage loss is VR, and then you see this terminal voltage. This terminal voltage, which is this voltmeter reading across the terminal of battery, this terminal voltage is actually the same as voltage across the external resistor. Do you see that? Let me draw to you. Yeah, you see here the voltmeter connect across these 2 points, isn't it? And this voltmeter below also connect between these 2 points. So this terminal voltage is voltage across here. And the VR is the voltage across here. And these two voltage is parallel to each other. Do you see that? This is the terminal voltage. Yeah, voltage across the terminal of battery, and this is the voltage across the external resistor. This is the VR lah. This is the VR across these 2 points. So this terminal voltage and this VR, do you think it's the same? Do you think it's the same? These two, VT and VR, is it the same? Of course the same, because parallel to each other, parallel. So VT must equal to VR. Do you see that? This VT, this is the, this is the VT. This is the VT. So this VT must equal to VR. You see, I already write here. This VT must equal to VR. Because they are parallel to each other. So VT is the terminal voltage. VR is the voltage across the external resistor. Voltage across external resistor, that means this is the, we also can say this is the voltage across the external circuit. We don't put resistor, we put the external circuit. External circuit. So the external circuit, or voltage across the external circuit, only receive the terminal voltage. It won't receive the EMF. The external circuit only receive VR, or the terminal voltage. It only receive the terminal voltage. It won't receive the EMF. Why it only receive terminal voltage? because there is voltage loss across the internal resistor. There are some voltage loss across the internal resistor. So it's just like the example just now. It's just like the example just now. The external resistor here only received 12 volt. Only received 12 volt because the terminal voltage, the terminal voltage of the battery is only 12 volt also. You understand? Only 12 volt. So the voltage across the external resistor here, 12 volt, it only received the terminal voltage of the battery. 12 volt. It didn't receive the 15 volt. Why didn't receive the 15 volt? Because there's voltage loss across the internal resistor, 3 volt. You understand? This VT and VR is the same. This VT and VR is the same because they are parallel to each other. Okay? See, the terminal voltage is less than the EMF. Because why? Because there's voltage loss across internal resistor. And this voltage loss across the internal voltage loss is the same as VR lah, which is the potential drop across the internal resistance of battery. Okay, class. Now, why I want to talk about switch close here? Why I want to talk about switch close here? You see, if I close the switch, there is current flow in the circuit, isn't it? There is current flow in the circuit. If you further derive this equation, voltage loss is the voltage loss across the internal resistor. So I can substitute with VR. Okay. Terminal voltage, the terminal voltage is the same as voltage across external resistor. Okay. So I can write E minus VR equal to VR. So this VR is IR lah, current multiplied internal resistor, and this VR is current multiplied external resistor. You see, or I change it back, VR is the terminal voltage. Okay, you see, E minus current E minus IR equal to VT. So, you see, when there is current flow in the circuit, when the switch is closed, there is current flow in the circuit, isn't it? When there is current flow in the circuit, so there is current. There is current. So when there is current, so you have IR. You have IR. So when you have current, then you have IR, then you have voltage loss inside the internal resistance. You have voltage loss across the inside the internal resistor. So that's why the terminal voltage will be less than EMF because got current. But if you, in the other case, if you open the switch, the current IR, the current is equal to 0. That case, the terminal voltage will be equal to EMF. Okay? It's not less than EMF, but it will be equal to EMF. This one I will talk about it later. Yeah. I just want you to focus on here first. All right. Why when close switch, you get the terminal voltage less than EMF? Because you have current. Because you have current. So when you have current, you have voltage loss across the internal resistor. Voltage loss. So it becomes like the situation just now. When there is current flow in the circuit, you see that? When there is current flow in the circuit, when there's current flow in the circuit, so you will have here, VR is IR. Okay, when there is current flow in the circuit, so here you have current. Yeah, here you have current. So that's why when you have current, you have voltage loss. So this internal resistance becomes significant. It becomes significant because got current, got IR. So that's why the terminal voltage, you won't get the EMF. You won't get EMF. Instead, you get the terminal voltage. The terminal instead you get EMF minus the IR, or this is called the voltage loss. Yeah, or we call it VR. You understand? So instead of getting terminal voltage equal to EMF, yeah, instead of getting the 15 volt, but there is voltage loss for 3 volt. That's why you only get 12 volt. You get 12 volt for the terminal voltage. The external VR also get only 12 volt. This is 12 volt because it is equal with the terminal voltage 12 volt. Understand? That's it. Yeah. When you have current, you have voltage loss across internal resistor. So that's why the terminal voltage is less than EMF. Okay, when the switch is closed. So I'm adding and then one more thing here. You see here this equation. E minus IR equal to IR. So if this IR go to the other side, it becomes this famous equation that we use during our high school, isn't it? Our high school SPM, you already learned about this equation. EMF, actually, this is the voltage supplied. This is actually the voltage supplied. But where is the energy being used up? The energy being used up in the external resistor and also used up in the internal resistor. That's it. Yeah. So use up in the external resistor and also use up in the internal resistor. That's it. Okay. So actually this formula come from here. You see, come from here. But in our syllabus, you will find this equation. This equation looks like new, but it's actually nothing new. This equation actually come from this equation. Understand? This equation actually come from this equation. They refer the same thing. The terminal voltage is actually the voltage across external resistor itself, and the voltage loss is actually the voltage across the internal resistor. Okay, the terminal voltage is the voltage across external resistor. The voltage loss is the voltage across internal resistor. Okay, so one more thing about the internal resistor. Why is it? What is actually the internal resistor? Why we have internal resistor inside the battery? It is because the battery has chemical reaction. It has a chemical reaction happening. We still remember we have the two pole. We have the two copper pole. So one will get thinner, one will become thicker. Those are chemical reaction. One got ionizes, one gather become a solid again. Those are chemical reaction happening inside the battery. So when you use the battery for a long time, you will find that the battery gets hotter and hotter, isn't it? It becomes hotter and hotter. Those are energy loss as heat due to the chemical reaction happen inside the battery. Those are the internal resistance. So inside the battery, you must understand the energy provided by the battery is not totally used up only by the external resistor. It also used up inside the battery due to the chemical reaction happening inside the battery. So that's why the light bulb outside will get hotter. The battery itself also become hotter, isn't it? So the battery use up energy, external resistor also use up energy. Inside the battery use up 3 volt of energy, outside resistor use up 12 volt of energy. Plus together 3 plus 12, you get back the 15 volt of the EMF, isn't it? Battery becomes hotter. Hotter after some time. This shows that battery also use energy. Okay, and for older battery has higher internal resistor. So that's why older battery, due to the higher internal resistance, become less efficient. Yeah, we prefer a new battery because has lower internal resistance. Okay, now let's look at the second case. What happens if I open the switch? What happens if I open the switch? If I open the switch, the current will become 0 because the current cannot flow in the circuit. Yeah, the circuit is incomplete. No current flow across the internal resistor. So when no current flow inside the internal resistor, we take this equation. We take back this equation. E minus IR equal to VT. Okay, we take this equation. When no current, I equal to 0. The 0 multiplied internal resistance. Current is 0 now. Yeah, current is 0 now. So 0 multiplied internal resistance will get 0. So we can say the voltage loss now is 0. No voltage loss across the internal resistor because no current. No current, we can say like there is no internal resistor. No internal resistor. So the terminal voltage, the voltmeter connected across the terminal of battery will get the EMF. That means this terminal voltage will get the 15 volt totally. Will get the 15 volt totally because no current flow. No current flow inside the circuit. Or we can say when no current flow, there's no potential drop across internal resistor of battery or inside the cell. Yeah, no potential drop across internal cell. So the terminal voltage, the voltmeter connected across the battery will get the reading of EMF. Instead, the external resistor won't receive any current. So of course, voltage across external resistor is 0. Okay. In other words, this one we can say that we connect the battery. It's like we connect the battery directly. You know, we connect the battery directly to the voltmeter. Yeah, this is the internal resistor. This is the internal resistor. This is the EMF. Okay. If we connect the voltmeter directly to the battery, this one measure the resistor. This voltmeter measure the terminal voltage of the battery. This one will get the EMF. Because why? This one is the same case as this one. Yeah, like the voltmeter here. The voltmeter here is actually connected directly to the battery. Outside here is like, because the switch is open already. Yeah. This one is like there's not existing here because the switch is open. So it's like this one is not existing. So this is just like the voltmeter connect directly to the battery. If we connect the voltmeter directly to the battery, we will get EMF. We'll get EMF. Some of you may say, oh, this is a complete circuit. What? The voltmeter connect directly to the battery. Actually, this become a complete circuit. So there should be a current flow. Many questions. Actually, this voltmeter has very, very high resistance. The resistance of the voltmeter is like infinity. You understand? It's like infinity. So actually, you know, here this resistance of the voltmeter is very high, infinity. So we can say that inside the circuit here, current is 0. No current will flow. No current will flow between the battery with the voltmeter. No current will flow between the battery with the voltmeter because the resistance of the voltmeter itself is infinity. So current is 0. Okay. So when current is 0, there is no, we can say the internal resistor is like not existing. The voltage loss is which is equal to IR because the I here is 0. So 0 multiplied internal resistance will get 0. So there is no voltage loss. There is no voltage loss inside the internal resistor. That's why the terminal voltage you will get equal to EMF. Okay. So that's it about these parts. So what I want to say is, when you close the switch, you will get the terminal voltage less than EMF because it is a complete circuit. You have current flow. You have voltage loss across the internal resistor. Okay, the terminal voltage will be less than EMF. The EMF maybe is 15 volt, but you only get 12 volt. You understand? You only get 12 volt. Yeah, less than that. But if you open the switch, the terminal voltage, both you get 15 volt. Yeah, you will get 15 volt because there is no voltage loss across the internal resistor. Like E minus 0, you get the terminal voltage. So terminal voltage is equal to EMF. All right. So that's it about these parts. Thank you for watching. So now let's look at the next video.